When we talk about AI chips, most people think of Nvidia, but AI chips actually come in several different forms, and many companies have a meaningful position in this space. Today, I'm going to walk you through 4 major AI chips. Before we get into that, let's quickly introduce the difference between traditional CPU and an AI chip. A CPU usually has only a few powerful computing cores. It's designed for complex sequential tasks, which is why it's ideal for our computers. AI chips, on the other hand, contain thousands of small cores that focus on parallel computing to handle multi-dimensional data structures called tensors. For example, when using AI to generate an image, millions of pixels need to be calculated at the same time, and that requires AI chips. There are 4 main types of AI chips. Most people know GPUs. And Nvidia is market leader. AMD, Intel are second-tier players. Hyperscalers such as Microsoft, Google, Amazon, Oracle are aggressively expanding their data centers, which has driven huge demands for GPUs. They buy GPUs from Nvidia and AMD, then rent out AI computing power to enterprise customers by hours or minutes. AI model firms like OpenAI, xAI, and Meta are also buying massive amounts of GPUs for AI model training. As a result, GPUs are in short supply, and because of that, Nvidia GPUs can cost $30,000 to $40,000 each. Here is the problem, because big tech companies rely heavily on Nvidia, and the GPUs are extremely expensive. Several big tech firms started developing their own AI chips based on ASIC architecture. Companies like Google, Microsoft, Amazon, OpenAI all have in-house ASIC projects to reduce the dependence on Nvidia. If a GPU is like a Swiss Army knife, very versatile, works for all kinds of AI tasks, then ASIC is like a screwdriver, extremely good at one specific job, but only that job. ASICs require huge upfront R&D expenses, tens of millions or even $100 million. But once they enter mass production, each chip becomes very cheap. That is why only large companies can afford to build their own ASICs. Behind these custom AI chips are Broadcom and Marvell, 2 companies with mature ASIC technologies. Broadcom supports Google and OpenAI, while Marvell works with Amazon. I estimate ASICs will eventually take up about a quarter of the AI chip market, while GPUs will still hold roughly 75% of the market. So both chips will continue to grow as data centers build out. ASICs only make sense at large scales. If the volume is too small, companies often turn to FPGAs. The upfront cost for FPGA is much lower than ASICs, and you can customize the chip, but the final products are not as efficient as ASICs. Many switches, routers, and network security devices use FPGAs. The 2 main FPGA players are Xilinx and Altera, which were acquired by AMD and Intel in recent years. Finally, we have AI chips designed for end devices, phones, tablets, laptops. A lot of AI tasks will eventually run directly on these devices, so they will all need built-in AI chips. Qualcomm, Intel, AMD, and ARM offer technologies for on-device AI chips. Apple also released its new M5 chip, built to support the growing computing demands on Apple devices.